All right. Let's see. All right, I guess we have enough folks to begin with here, so I will kick it off. So welcome to the March 10th SIG KubeVirt SIG storage meeting. So far as we can see from the screen, we don't have any agenda items. So just wanted to call for open floors or anything we can add there. I can take some notes if anyone has topics they'd like to discuss today.
I actually have one. I just put it in the wrong day. So
Oh,
Adam,
okay.
see if you can copy that one from me to today. And thank you, Steve.
Yeah, no problem. That's a problem I can easily solve. There we go.
Yeah. Um, so brief introduction on the problem. So for those of you that have been followed the PR from Jed for TPM, knows that already, but let me summarize quickly the problem. So currently we call it interrupted migration. So basically it's a race condition that happens when the source launcher as crashes, but the migration is still ongoing. So it means migration is still ongoing at KubeVirt level. But for LiveVirt, it could have already switched to the target. So the domain is basically running on the target. This can happen with pre-copy in the case the guest start running on the target and there is some delay in updating the VMI object, or especially for post copy. Because for post copy, when we finish to copy the storage from the source to the target, then the domain start running on the target. So why this is a problem for storage? So we have this problem for TPM and for volume migration because each launcher has its own copy of the storage, and the writes goes where the domain is running. So if there are some doubt or there is some crash, basically we don't know anymore which is the right volume to use. If it's the one from the sources, it's the volume from the target. So we solved this with TPM, but we still have the problem for volume migration.
Could you explain a little bit how it was solved for
Yes,
TPM? I see
yes,
this after this
yes.
PR.
Yes, so basically we rely on backend storage, and keep this in mind because this is actually the question I have. So basically we use backend storage, and LiveVirt basically will create a file on the backend storage to signal that the migration is complete on the source. So when there is this crash, basically what Jed did in this PR, we create a job that basically verify if there is this file in the source. So if the file is present in the backend storage source, it means that the migration has completed. So basically the correct volume are the one on the target. On the other way, if there is no file, then it means that the migration hasn't switched to the target, so the right volumes to pick are the one from the source. So, and basically, KubeVirt is picking the correct backend storage for TPM. So this is already merged, but we need to fix this for volume migration. So for backend storage, for TPMs, it's relatively niche because it's just for VMs that actually use TPM. But the problem for volume migration, it can happen for any VM. So the idea was to extend the backend storage for all type of VM. But we have multiple problems for it. So first of all, there are certain storage drives that only create 4 GB volume.
Yep.
And of course, if we require now each VM to have this backend storage, it means every VM consume at least 4 GB. So this is the first problem. The second is that I just saw that we don't support restoring for VM with backend storage. So I don't know why it's the case. And I wanted to ask you maybe if Shelly is here or if somebody knows.
Are you sure this statement is true?
Yeah, because we have it in the I saw it in the code in the webbook.
So
If you-
Alvaro's not here, but
Mhm.
he just recently added a bunch of code to fix like VM snapshot and
Okay.
restore for
Mhm.
TPM. So as far
Okay.
as I understood, it was supposed to be fixed.
I see. Okay. Then if
What's the
my
question?
sorry.
What's the question?
The question is if we support the restore of VMs with backend storage.
Yes, now we do.
Okay.
As Adam said, Alvaro added it lately. We still don't support clone with TPM though.
Yeah. And Shelly, do you know if it's because of the backend storage or for any other reason, the clone?
Yeah, the clone checks if there is a backend storage, and if so, it prevents creating the clone in the webhook.
Then maybe, yeah, I don't know. I saw restore in the causes, but maybe it's actually the clone. But yeah, in any case, it's still a problem because if we extend the backend storage to all VMs, basically we are preventing a VM to be cloned.
Yeah.
Did you consider instead of extending backend storage to all VMs, maybe a different way to communicate from the source
Yeah.
to the target?
Yeah, this is the other option that we don't currently have. But we could extend libvirt, but that's another discussion that we need to have with the virtualization team.
No, I mean with the given libvirt you have now, like for example in CDI we exchange some information through the termination message API on the pod.
Okay.
Maybe that can work here. Does libvirt locally have this information?
I don't think so because it would mean that libvirt can patch the pod. Or,
But I'm not sure what exactly is the issue with clone of VM with TPM though.
I could explain that one. I think it's orthogonal to this problem at hand, though, so I hesitate to jump into it now. But I remember the reason for that, which is basically, I'll say quickly that for TPM, since it contains keys,
Yeah.
or can contain keys, we are hesitant to clone the VM and its keys because then you now have essentially two copies of the same virtual machine, and TPM is supposed to kind of ensure that it's unique hardware. So I think we weren't sure about the semantics if you should actually clear the TPM for the cloned VM. But in certain cases, if you're using like BitLocker, for example, that would lock you out of your VM file system. So it's not exactly clear what the correct semantics should be there. And I think we're still working that out.
okay, but
But it's something you
sorry.
plan to fix, right?
I mean, it will need to be for sure. And I'm not sure where that's exactly tracked. If I think Alvaro might have an issue for that, but we should check with that.
Yeah, because eventually I think also for the backup, if someone will want the incremental backup, it will also require the VM state PVC. Although again, if currently if there is TPM, then we are not allowing to do the clone. Or if you are planning to use TPM specifically, or you want some other PVC like I want.
No, I mean, if it's just a TPM, I'm not interested in the TPM. I'm interested in the backend storage.
Yeah, exactly. I'm also will need that. So I think that the issue with the clone is not the backend storage per se, it's more the TPM in it, right?
Yeah, looks like this, yeah.
Yeah, I mean, we do have this. I mean, Alice is right to bring up this issue about the provision size of TPM, and we're going to be seeing this more and more. I think we've seen with Trident storage, for example, in a particular scenario where somebody was using a ton of Windows 11 VMs, and it's essentially doubling the amount of PVCs and storage that are needed. So this is going to be a problem that we want to think about. I've been spending a little bit of time trying to think about this, if there'd be a way to have, like, for example, one large PVC that hosts the VM state for multiple virtual machines, and whether that's something that we could do, like, as a way to handle this. It makes things more complex with migration and things like that, of course, because we don't want to require that it's read write many file system. So is there a way to share? I'm not sure.
Yeah,
but that would
we did allow, like, at first we asked for the backend storage to be RWX, but now we are allowing it to be read write only.
Right. Read write once is working, but then if you're sharing that between multiple multiple VMs on a node, for example, like this is something that I was thinking about, is could we have a singular node level PVC, which maybe is associated with the vert handler, and that's carved into directories, and then basically shared out somehow to the VMs that are running there. In the case of live migrating a VTPM enabled virtual machine, that's copied anyway. So the new PVC would be the vert handler shared PVC on the receiving node. But for other things, and like for incremental backup, for example, that could potentially work, except for then we'd have to explicitly deny the use of live migration during a backup. But I was wondering about that. The other thought that I actually was talking with Jenia about this the other day, because she kind of had the idea, but if we were able to always have a VM state storage class, which essentially would be HPP. So you know how in we can use an existing PVC from regular storage to back an HPP storage class. So one of the things that I had thought about is, and Genia as well, is if we had just like we have a vert default storage class, if we had a VM state storage class that was always configured as an HPP store on top of whatever the vert default storage class was, then you could efficiently create a bunch of PVCs on there that aren't subject to the size limits of the underlying provisioner. We still have the problem with the idea of live migrating and stuff, because that HPP storage class would still be read write once file system, and also currently HPP doesn't support snapshots, which would be required for snapshotting the TPM.
So it sounds like the second point I wrote there, it's solvable, but the first is the real issue.
The first is the bigger issue, and it's biting us in a couple of different ways. Like we're already getting, I think, pushback from end users that are already annoyed that there's a PVC per VM disk. I mean, that's the Kubernetes architecture that we settled on. You know, but like by having, if you have an environment where lots of VMs are using TPM, and exactly what Alice is talking about would be here. And also it's relevant for Shelley's incremental backup work, because once we have that feature, everyone would want the VM state PVC for all VMs, whether or not they specifically need it. So we are going to have this problem of more of these wasteful, if you will, PVCs around in the environment. It's a problem that will need to be fixed.
Yeah, and it seems pretty urgent. I mean, because the other way could be that we fix more or less this race condition differently and not requiring storage. But yeah, it sounds like we need in any case to solve this problem. Yeah, not an easy one. I don't know, HPP, it's not always. Adam, how would you solve it with HPP? Would you require that HPP is mandatory?
So if I was gonna solve it with HPP, you could even do this in an automated fashion with a controller. So we already have the idea of creating the HPP CR by saying allocate a PVC from this storage class. So theoretically, if you had a Vert default storage class or a Kubernetes default storage class, you could have an entity within the system automatically configure HPP of a certain size. It would then essentially create a VM state, you know, OpenShift virtualization VM state storage class on the cluster. And then every time a VM needed a VM state PVC, it would just allocate one from there. And the advantage of HPP is even though you're allocating of a certain size, you're only using the space on the shared file system. I mean, it creates other problems, like, for example, what size should that PVC be? And this would vary depending on the environment. What happens if the environment grows and we're running out of space? We'd need to expand that PVC and grow the file system that's on it. We need snapshot support for HPP, which has a problem because of.
Do we need snapshot? Do we need snapshot?
If you want to be able to snapshot virtual machines, yeah, because
yeah,
you
okay,
need
for the TPM, yeah.
Yeah, we don't need it necessarily for your specific use case, and we don't really need it for incremental backup, but for general, I mean, unless you exclude the state PVC and ensure that everything else is handled, but you do need to snapshot the TPM device. So, unless we had completely out of band handling for snapshotting, that it would be very problematic. I think that's a big issue. And then it also doesn't solve the problem about if the VM is located on a different node from where the original storage was. Like for incremental backup, again, for VM state, that's not a problem, but for restoring a VM back or a snapshot on HPP, that's not shared storage. So it would have to restore to the node where it was taken, which is a bit odd. So
yeah, or you need to copy that one.
Yeah, so I'm not sure if that's actually going to be, this was something that I was going to I think this came up in the middle of the week last week, and I had actually forgotten to mention it here. So I'm glad that you guys brought this up. That was one problem that I considered. And I think the other one would be is if we could just somehow have a VM state PVC that's associated with virt handler instead of with virt launcher.
Yeah, I don't know because I think it's hard because PVCs are namespaced. And I don't know, would you create the PVC in?
Oh, yep, you're right.
Well, no, you would create the PVC in the KubeVirt namespace. And the virt handler would have to ensure that the VM state information is associated with whatever VM is in whatever namespace.
Oh yeah, you could bind mount the directory.
No, guys. Let's try to avoid by month. We're trying to get rid of what we have already.
Okay.
Please
Yeah, so then
don't add others.
I don't think you would need bind mounts.
I don't know because for TPM for sure you need to provide that to QEMU.
yeah.
And for libvirt, I mean, at least they need a directory.
No, I'm saying on the HPP level, both HPP and the virt handler within the KubeVirt namespace, and when you create, when you mount or you create the PVC from some other storage class, that's the backing PVC that then gets mounted, you know, in on the node.
Yeah.
And the HPP created volumes don't care which namespace you're using. I have a ton of other issues with this suggestion. The biggest one being that we need to be copying these TPM state all over the place. We'd actually have to probably synchronize it across all nodes all the time.
Yeah, so Alexander, you're talking about the HPP approach. I think Alice and I were digging into the virt handler associated PVC idea, which has the bind mount issues. HPP would not. But yeah, I think, and then yeah, I think the virt handler associated one is a non-starter because also when you still have the snapshot problem because you don't want to snapshot you wouldn't want to snapshot all the VM data from all the VMs as part of a single VM snapshot. So you do want to have, you know, VM specific data there. So, but I think the nice thing about the HPP VM state storage class is like, we still need to solve all these other problems, but like it's an optional way to get around the size limitation, but it does create a couple of other problems.
I believe we actually already have a state, you know, cluster-wide state storage class variable in the KubeVirt CR.
We do. Yep. So
yeah, we
honestly,
have is what I'm talking about here about the 4 GB volumes.
Yep. So we already have most, like, in fact, we could kind of already test this idea today with everything that's there. We would just create an HPP storage class on top of whatever existing storage class was there. We would configure that as the VM state storage class in the KubeVirt CR, and then like I think it would, like, in general just work. The problem, it would even work with live migration today because live migration allocates a new PVC on the target node. The main problem that we have with this approach is snapshots. And so unless we could come up with a peer-to-peer syncing of the snapshots so that it could be restored on whatever node it needs to be restored on, and we don't have snapshot support yet in HPP, and I think this is why, Alexander, you stopped with it, because of that idea that it's it's limited. Stores are limited to the node where the snapshot was taken.
Right. Yeah. I didn't want to get into the business of synchronizing stuff across nodes. But
Alicia, could you? Sorry.
Go ahead.
So I wanted to ask if you could elaborate on what libvirt exactly writes into this file that you were planning on reading.
It just create a file. It's literally a touch.
A stamp. Yeah, it's a stamp.
So, yeah, so it's more so the reason to use the termination message API if it's like not changing, not dynamic. It's just about signaling.
So we haven't considered this about I have to admit I am very ignorant. I don't know how it works. But that was the suggestion. I mean, we have for TPM. If there is something easier that we can use, even for TPM, that will be for sure.
But Alex, if for the termination, like the libvirt D is not the root process, so I forget how the termination. We have like a JSON object for termination, right? So that you can pass structured data, and so you can pass multiple messages. But I don't remember how that works. Is it just in a file that you write?
Yeah, whatever you write to this file path will get reflected into the pod's status termination message entry. So if you just leave that virt launcher pod completed or failed, whatever the state was, you could then read from that field and deduce whether the file was created or not.
That would be, I think that would, yeah, I'm not sure. So if the pod stays around, yes, but if for any reason the VMI is deleted,
yeah, you'd have to attach
yeah,
I'm sure one of the problems is going to be to attach yourself to the part that decides whether to delete this crashed or completed pod. I'm sure we clean it up ourselves. Like I've seen the pod manifest.
No, but actually I think it could work, Alex, because so basically we said the migration object failed, and then if I remember correctly, migration object stays around until the VMI stays around. So if the VMI is gone, is everything gone, I think.
Yeah, I can give you the CDI reference, but
yeah, that would be great, and I can discuss this with Jad why we didn't. I don't know, maybe because it's Jad that implement the TPM, maybe I don't know if they consider it. I don't think it was one of the options, so there might be something that could facilitate our life. To be honest, the PR that Jad wrote is pretty complex. If we can get rid of it and have something simpler, it will be just good. Yeah, Alex, please ping me and yeah.
I'll attach it to the document.
Oh, okay, great.
Yeah, and I do think that this is going to be, so regardless of how we solve this problem, which is definitely important, we are still going to have the TPM device issue. And so if everyone here and others, if we could be thinking about this, if there's a better way to have a state PVC that's like more efficient, that's going to be a problem that we'd like to address somehow. And I'm not really sure what the good answer is for that right now. But
yeah, I don't know. I have the impression we need to separate the backend storage from the TPM problem. I know that the TPM is on the backend storage, but it becomes very, very complex otherwise. Because the problem is that you cannot control which storage class you have in the cluster.
Mm-hmm.
So you don't know if the backend storage supports snapshot or not. I don't know.
Well, we basically, I mean, this is why I always, I guess, this is one of the reasons that I was originally advocating for storing the VM state PVC on the same storage class as the root disk, because then if that storage class doesn't support snapshots, then it's not a new problem that we created, because like the VM already can't be snapshotted because they don't have snapshot capable storage. Whereas if, yeah, we have a different storage class or HPP, for example, then yeah, we layer on additional restrictions that may not have existed there with the original storage.
And the problem was the for block, or because we use space, or what was the problem?
The problem is that, well, first of all, it's an additional PVC object per VM, and some people get, when you have clusters with hundreds, if not thousands of VMs in them, if you're doubling the number of PVCs that exist in the system just for these, you know, couple of kilobytes of data, that's one issue. It's the number of PVC objects doubles, but also probably more critically that a lot of storage only, like, it has like a minimum size of 4 gigs or whatever. There's different minimum sizes. We've found this with lots of the cloud providers, but also with you know, with other storage that typically we're asking for what is it, 10 megabytes or something. Obviously that number will go up when we have incremental backup. We'll probably ask for a bit more than that, but it's still a relatively small amount. And so to waste 4 gigs of backend storage to provide 10 megabytes of needed storage.
That's clear.
Yeah, that's the other issue. So it's number of PVCs and then wasting the storage, because these vendors aren't designed to offer small amounts of data. And so then the idea was, okay, well, can we use one PVC to service multiple virtual machines or something like that? But I don't know. Or even like a PVC per namespace.
Yeah, I was thinking exactly the same. Per namespace looks a bit more reasonable to me, but yeah.
So that's something that it would be great if everyone could kind of mull over a little bit. I've been thinking about it too, but it's a problem that we will be forced to solve, and it'd be nice to solve it before we're under duress to solve it.
Yeah.
As always, right?
So how do we want to proceed with this? I mean, we talked with Judd about what Alex suggested, but about the backend storage, in my opinion, I don't know if we should discuss with the community, at least summarize, because we have at least 3 different topics. So we have at least TPM, volume migration if we cannot use CDI solution, and incremental backup coming up. I don't know if we have other cases where we need backend storage.
Those are the only ones I'm aware of for right now.
But are already quite important, so yeah.
Yeah, and yeah, as soon as incremental backup lands, everyone will use a VM state PVC, because I think, well, most people will want this capability once it's there, I would say.
Yeah.
So yeah, it's basically, I think this problem's gonna need an engineering owner, like somebody who cares enough about it, that wants to drive it. Like, I think there's gonna need to be some discussions had. There'll probably need to be a cap at some point, or not a VEP at some point, to change the way that we store that once we have an idea, and then it's gonna have to get you know, push through. But I'm hoping that we could think of, you know, if we have somebody that sits down and thinks about it, like for example, the namespace leveled state, and pretty much if the rules are that all the state can be migrated by QEMU or discarded when not needed, then the PVC doesn't have to be read write many, it can still be read write once. But yeah, and I think that could be the case for well, no, not really. Well, yeah, I don't know. Shelly, QEMU migrates the oh, you probably haven't tested that yet, but that was one thing that'd be interesting is does QEMU migrate the QCOW2 overlay file, or does it have to exist in shared storage for migration?
It migrates the QCOW overlay file. We already do that with migrating like container disk-based VMs. There's an overlay on there, and you can migrate those, and it migrates.
Oh,
it copies the QCOW2 overlay.
okay. Because all we're storing there is the changed blocks, but those would have to move. But if QEMU handles that and QEMU is handling the TPM, then it's okay. That all should be okay. And then the question would be is, if you wanted to have a per namespace, but that it'd be per namespace per node is what it would end up being, because you'd create the new one on the, so I don't know how much that would actually, it would reduce it by a little, but not necessarily a ton. Okay. Anyway, it's going to need somebody that's going to sit down and think about what the reasonable options are there. So I guess it sort of falls into, depending on what feature we want to associate it with, but it's definitely going to need some collaboration.
Yeah, I think the first question is who is going to need this first, if it's me or.
Well, you may be able to fix.
Yeah, I
with
might
the
be able.
term.
Yeah.
But the real question is that adding additional complexity that if we actually solve the VM state PVC problem, you know, if all volume migrations and TPM migrations could be handled by stamps within the VM state PVC, then although those don't migrate, the stamps don't migrate, but
No, it's no, the stamp is just an ugly hack in my opinion. If we could get rid of it, it's just easier independently of all the backend storage discussion. But it's right now what we use, so yeah.
Yeah, I'm trying to think if there's something that could monitor without in a non-raceful way, if there is something at the vert handler level that could like atomically detect completions and then update states of operations.
Theoretically we should be getting events from libvirt. I mean, if it was possible to query the state of the migration on the target as well, because the target theoretically is still running.
Yeah.
Then that would solve, but libvirt is not really sending it. The source has more information. That's the problem.
Yeah, so I will say that this is bringing up some ghosts and demons into my mind from work that we did on Rev, because we had the same problem with live merge when you were deleting QCOW2 chain members, and at any time if you lost the VM. And the conclusion that we came to back during that work is that the storage itself has to be the source of truth, and you shouldn't rely on, because otherwise we can always find a situation where, let's say, the VM was migrating and yeah, like you lost the cluster or something, you lost part of the cluster or something, you still want to be able to recover that VM off of the disk if you reinstalled the system, for example. And so that's like a much more difficult situation to produce, but it'd be nice to be resilient to that, like to know what is definitively what is the volume that contains the newest data. And in Rev, or Overt, we used actual like logging in the like metadata logging on the disk itself to indicate whether these operations completed, so that you could actually look at the disk itself to determine exactly what the state is.
Yeah, I mean, what Alex was suggesting should be in HCD, so the metadata in this case is the pod, and even if the cluster crash, we should be able to at least recover the Kubernetes objects. So that might be reflect, Adams, to what you are describing here with the logging
Yeah,
metadata.
sort of. I mean, if etcd, I don't know how easy it is to recover etcd on a like a totally messed up cluster. But yeah, if that's, I mean, I think there's plenty of other problems that can happen if we start to think about those failure
Yeah, because
scenarios.
otherwise you don't have the PVC objects anymore. You don't know which storage is associated to which VM. Yeah, so
And this is where you have backups. You know, this is why you recommend backups, so you could actually go back to a sane point in time. So yeah, maybe we don't have to be quite that pedantic. Okay. Yeah, so it sounds like the first step is to look at that
yeah, we'll
CDI reference and see if we can solve this generally for volume migrations, and then the VM state PVC problem is a separate issue, which is also very urgent.
Yeah.
About the etcd failure, it should be more or less similar to, you know, databases. So etcd is really in practice not replaced a lot. People use etcd in their clusters, but there is everything you need in place to use Postgres or something, and it all works. So forget where I saw that, but so you shouldn't have this problem. You shouldn't be worrying about that. There's like a WAL, write ahead logging. So the entire log gets written before you flush the disk. So you don't have to spend a lot of time on data loss scenarios.
Okay, that's good to know. All right, so I do wonder in terms of the broader like VM state issue, how do we want to, like, if we don't do anything now, it's gonna just live in these notes, and it's not going to, it'll be addressed later, like we'll drop the ball. So I'm just wondering, what do you guys all think would be the best way to at least get this written down somewhere? I don't know, we don't necessarily need an owner for it quite yet, but
So I had a random thought just now. What if we use an S3 bucket backed storage class for the you know, metadata stuff? So, you know, we require the user to have an S3 type storage class, you know, Ceph provides one or two out of the box, and I'm sure all the cloud providers have some S3 based storage class as well. And we just use that to store all the metadata. And that should work across nodes and things like that. So, which is the red.
So I'm not even sure how those work. Like when you start the VM, it pulls the data from S3 to populate it, and then what happens when you stop the VM? Does it push it back to S3 when you like detach it?
I would really have to look exactly at how the details work, but I believe the S3 bucket just gets mounted just like any other file system. So
Okay, because I thought S3 it wasn't something like that connected back to this. I thought you pull the data down like it's a download, and then it basically S3 doesn't support writes, it supports download and upload. So, but yeah, that'd be something interesting. Like it'd be another way but it would add another flow because I think there'd be some people who would want just the PVC flow. Unfortunately. And so the question would be like, do you want to provide multiple ways to manage state? And probably not.
Well, we'd have to look into exactly how these, S3 storage classes work exactly, because I think they come with like object buckets or something like that, and we have to see how that works. But that might be a solution for storing stuff that's relatively small and cross nodes. I don't know. Just a random thought I had.
Yeah. Okay. I wrote it down there. So I guess for now it's just going to be a thing in the back of our mind.
And if that's not possible, I hate to even suggest this, but could we write a CSI driver that is backed by like an etcd or an S3 bucket or something that's goes across nodes, and that just provide PVCs to the actual pods, but in the end it gets written to whatever cross node backend that it means another CSI driver, which I don't really want to do, but we could tailor that CSI driver to solve our specific problems.
Yeah, I thought about like also if you had something dumb like
basically instead of HPP have one that's really specifically designed for solving this problem. So
I mean you could also solve it with like a cluster provided NFS or God forbid Samba. That wouldn't perform well, but like having like on cluster file sharing. There's a few different ways, but in terms of something this is something users don't want to think about at all. So like that's why I'd love to, like when I was thinking about the HPP idea, like we could actually configure that automatically. We already have it. But yeah, like with that
but
one,
HPP has some issues that we don't really want to deal with. So that's why I was thinking maybe if we have a different CSI driver that does not have these issues, that we can automatically install and configure for them.
Yeah, but I don't think we can restrict VMs to a specific CSI driver.
We can restrict the metadata PVC to be a specific CSI driver.
Yeah, but we want to extend this to all VMs.
Yep.
So it needs to be a generic solution. It's not like a Windows VM that needs to use TPM and that specific storage class.
Yeah, once we have incremental backup, you can expect that the majority of VMs will be configured with a VM state PVC.
Yeah, and let's suppose that the CI trick doesn't work. I mean, that the pod same for volume migration.
Yep. I'm gonna add the other idea that came up as well, which was what about having a shared VM state PVC per NS per node. That would at least, if you had a 10 node cluster and you were running VMs in 3 namespaces, you could have 30 VM state PVCs that were managed by the system, and maybe you're running 100 VMs or something like that across those that environment. Instead of having 100 PVCs, you'd have 30. And potentially you could still manage the size of those to be something reasonable. Then you're constantly like, well, what should the size be? So, and then you'd have to manage expanding them and things. It's tricky. Okay, so we're kind of at time on this one. I think that's an open problem. It'll be a good one to ponder for all the smart people in the room. And yeah, I think we're out of time. We're about 5 minutes over. So Alice, thanks for bringing this topic.
I didn't want to monopolize the entire hour. Sorry.
Well, it turns out it's a
Common
I think
issue.
it's probably one of the more important topics of the day. So I'm glad you did bring it up. All right. Anybody else have anything else to raise? Anything quick that we can help address while we're all together? All right. If not, then thanks for joining, and we'll see you at the next KubeVirt SIG storage meeting in 2 weeks. Have a great week. Thanks.